Hello there, and welcome to the Sleepy Nature Channel. Have you ever stood at the edge of a quiet lake and felt like the water was breathing? Or held out your hand in the rain and wondered where those tiny drops had been before they found you? Water is everywhere. In the clouds above you, in the roots beneath your feet, inside every living thing on earth. It moves in secret, rests in the deep, and travels farther than you could ever imagine. Tonight, we're going to follow water, all the way from the mountaintops to the oceans, from the tiniest raindrop to the oldest glacier. Let it carry you gently into rest. Find a comfortable position now. Let your body sink softly into wherever you are. Take one slow breath in and let it go. The water is already here, moving quietly around you. All you have to do is listen. There is a place where the world is very still, where the only sound is a soft drip, one drop and then another, falling from a mossy rock into a small, dark pool below. The pool barely ripples. It simply receives quietly, as it always has. Water has been doing this for a very long time. In fact, the water on Earth today is the same water that has always been here. It doesn't disappear. It doesn't run out. It simply moves from sky to ground, from ground to river, from river to sea, and back again. The water in the glass beside you right now may have once been part of an ancient ocean, or a cloud above a jungle, or a river that flowed through a world that looked nothing like ours. It has been traveling for billions of years, and tonight it found its way to you. That thought is something worth sitting with for a moment. The water inside your body, in your blood, your tears, your breath, is ancient. It is older than almost everything you can imagine. And yet, here it is, warm and alive, quietly doing its work. Let's begin at the very beginning, high up in the mountains, where the air is thin and cold, and the rocks are covered in a soft, powdery white. Snow gathers slowly on mountain peaks, flake by flake. Over months and years, it builds into something heavy and deep. This snow doesn't melt quickly. In fact, on the highest peaks, some of it has been there for hundreds of thousands of years. We call these ancient frozen rivers glaciers, and they hold about 69% of all the fresh water on Earth. 69%. Almost everything that is drinkable and fresh locked quietly in the world's highest, coldest places. A glacier moves, not quickly, not in any way you could watch and see, but it moves, drifting downhill at the pace of just a few centimeters a day. Inch by inch, it creeps. As it moves, it carries stones and grit inside it, slowly carving the shape of the mountains themselves. The wide, deep valleys you might have seen in photographs, the ones that look like they were scooped out by a giant hand, those were made by glaciers, patiently working over thousands of years. At the glacier's edge, in warmer months, the ice begins to soften. It melts at the edges, releasing thin streams of meltwater that trickle down the rocky slopes. This water is extraordinarily clean. It has been frozen for so long, so high above the world, that very little has touched it. It runs cold and clear, picking up the faint mineral taste of the stone it travels over. Those little streams find each other. They meet and merge, growing slowly wider and faster, tumbling down the mountainside in small waterfalls that catch the light and scatter it into tiny rainbows. On a sunny morning, A mountain valley can shimmer with dozens of these little rainbows, each one brief and perfect. As the water descends, it begins to slow. The steep slopes give way to gentler ground, and the rushing stream becomes something quieter, a river, walking now instead of running, moving in long, soft curves through meadows and forests. A river bends and loops because of something beautiful about the nature of flowing water. When water travels around a curve, the outer edge moves faster than the inner edge. This gradually wears away the outer bank and deposits sediment on the inner bank. Over many years, the bend grows more and more pronounced, until sometimes the river curves back on itself almost completely, forming a shape like a bow. Eventually, the curve becomes so extreme that the river finds a shortcut and cuts across, leaving a quiet, curved lake behind, called an oxbow lake. These still curved pools are among the most peaceful places in the world. They sit apart from the river, no longer moving, simply resting. The river, meanwhile, carries its water onward, and it carries more than just water. A river is full of invisible passengers, minerals dissolved from rocks, tiny particles of soil, microscopic living things that drift and spin in the current. When a river finally reaches the sea, it delivers all of this. The mouth of a great river is one of the richest places on earth, where fresh water and salt water meet and swirl together, creating a warm, cloudy, nutrient-rich world. This meeting place, the estuary, breathes with the tides. Twice a day, the sea pushes inland, flooding the river's mouth with salt water. Twice a day, it pulls back. The mud that's left behind is deep and dark and extraordinarily alive. More species of birds, fish, and invertebrates live in estuaries than almost anywhere else. The richness of life there comes entirely from the river's patient delivery. Everything it gathered from the mountains, the forests, the plains, all of it brought here to the edge of the sea as a gift. And there, at the water's edge, where the last of the river slips into the ocean, you might stand and feel something very particular: the sound of water, meeting water, the smell of salt and mud and green growing things, the soft cry of a bird overhead. Water has arrived, and it is already beginning its next journey. The ocean receives the river's water, but it gives back too. Every day, the sun warms the surface of the sea, and water evaporates, rising invisibly into the air as vapor. You can't see it happening, but it is always happening. Everywhere there is open water. The sea breathes upward constantly, generously, sending moisture into the sky. That moisture gathers. It cools as it rises, and cooling causes it to condense, to come back together into the tiny droplets that form clouds. A single cloud can hold hundreds of thousands of tons of water. It drifts with the wind, traveling perhaps thousands of miles before the droplets grow heavy enough to fall. And then, rain. Rain has a sound that is like nothing else. The first drops on dry leaves, the soft patter on still water, the deep drumming on a tin roof. Rain returns the ocean's gift to the land, completing a circle so old and so continuous that the water falling on you in a summer storm may have evaporated from the sea just days ago, or weeks ago, or perhaps 1,000 years ago, from a sea that no longer exists. Before you drift a little deeper, if you're enjoying this story, feel free to like this video. It helps others find their way here too. Now, close your eyes gently for a moment. Feel the weight of your body. Think of water, somewhere quiet, somewhere soft. A pool beneath a waterfall, still and cool. Let yourself rest there. There is a particular sound that water makes when it moves through a forest. It is different from the sound of water in the open. Softer, more muffled, broken into pieces by the trees. You hear it before you see it. A low, constant murmur, like someone speaking very quietly in another room. Water and forests have always belonged together. A single large tree can absorb hundreds of liters of water from the soil each day, drawing it up through its roots and into its trunk, its branches, its leaves. And then, through tiny pores on the surface of each leaf, the water evaporates, breathing out into the air above the forest. This is called transpiration, and it is happening constantly in every forest, in every season when the leaves are out. A large forest transpires so much water that it actually creates its own weather. The Amazon rainforest, for example, produces so much water vapor that it generates what scientists have called flying rivers. Enormous, invisible rivers of moisture moving through the air above the jungle, carrying as much water as the Amazon River itself carries on the ground. These aerial rivers bring rain to places thousands of miles away. The forest keeps the rain falling. The rain keeps the forest growing. It is a perfect, patient agreement. Beneath the forest, the story continues underground. When rain falls on a forest, some of it runs off into streams and rivers, but much of it soaks into the soil, drawn downward by gravity through layers of earth and sand and rock. This water moves slowly through the ground, sometimes just a few centimeters a day, but it keeps moving, and eventually it may reach a layer of porous rock, sandstone or limestone, where it gathers in the spaces between the grains. These underground water reserves are called aquifers, and they are among the most important things on Earth. They hold water that fell as rain decades, centuries, sometimes thousands of years ago. In some dry parts of the world, people draw water from aquifers that filled during the last ice age, when the climate was different and the rains were heavier. Ancient rain resting in the dark beneath our feet, waiting patiently. Sometimes, aquifer water finds its way back to the surface on its own, rising up through cracks in the rock to form a spring. A spring is one of the quietest miracles in nature. From apparently dry ground, clear water simply appears. It bubbles up, cool and clean, and begins to flow, forming the beginning of a stream that didn't exist before. Springs have always felt magical to people. In many cultures throughout history, springs were considered sacred places, gifts from the earth or from whatever lay beneath it. And in a way, they are gifts. Underground water that has been filtering slowly through rock for perhaps 1,000 years, emerging clean and cold and ready. The water that rises in a spring carries with it the minerals of the rock it traveled through. Limestone springs produce water rich in calcium, the kind of water that, if you leave it in a glass and let it evaporate, leaves behind a faint white ring. Volcanic springs carry sulfur and iron. Some springs are warm, heated by the Earth's own interior warmth, and these are called hot springs. Around hot springs, where warm mineral-rich water meets the air, extraordinary things grow, bright orange and yellow mats of microscopic life, unusual mosses, ferns that curl in the steam. Yellowstone, in the American West, is full of hot springs and geysers. places where superheated water shoots up from the earth at regular intervals. Old Faithful, the most famous geyser there, erupts roughly every 90 minutes, sending a column of hot water and steam high into the sky. It has been doing this for hundreds of years. Visitors come from all over the world to watch it, and every time there is a moment of silence just before it erupts, a held breath, a stillness, and then the water rises, glittering against the sky. But we don't need a geyser for wonder. Even a small puddle, left after rain, holds its own small world. Tiny creatures live in puddles, water bears, which are among the most indestructible living things on Earth, and single-celled organisms that move with tiny hair-like paddles, spinning and gliding in the water. A puddle may last only a day, but in that day it is entirely alive. Water at rest reflects the sky. This is one of the simplest and most beautiful things about it. A still pond becomes a second sky. Clouds moving across its surface, the silhouette of a bird passing over, the blue deepening toward evening. Ancient peoples believed that still water was a portal to another world. And looking into a perfectly calm lake on a clear day, you might understand why. The reflection is so perfect that for a moment you feel like you are looking down into something infinite. If this story is helping you unwind, we'd love to know. A comment below means so much, whether it's just a word or two about how you're feeling tonight. Water has memory in a way. Not in the way that living things remember, but in the way that it holds the shape of things. When water flows over stone for long enough, it wears grooves and channels into the rock, pathways that guide every future drop that passes. The stone remembers the water in the shape it has become. The ocean is the largest thing on Earth, larger than all the land combined, deeper in some places than the tallest mountains are tall. And yet, if you have ever sat beside it in the late afternoon, watching the light change on the water, you know that it can feel very gentle, like a breathing thing, rising and falling. The ocean covers about 71% of Earth's surface. Most of it, the vast middle distances, we have barely explored. More of the ocean floor has been mapped than some might expect now, but still, the deep places remain largely unknown. The deepest point on Earth, the Mariana Trench in the Pacific Ocean, reaches nearly 11 kilometers below the surface. If you placed Mount Everest at the bottom, its peak would still be more than 2 kilometers below the waterline. In those deepest places, there is no light. No sunlight has ever touched the walls of the Mariana Trench. And yet, life is there. Strange, translucent creatures, shrimp, sea cucumbers, tiny fish, living in the complete dark, under pressure that would crush anything built for the surface world. They have adapted over millions of years to a world of cold and darkness and enormous weight. But the ocean is not only deep, it is also, in many places, brilliantly alive near the surface, where light can reach. Coral reefs, those living structures built by tiny coral animals over thousands of years, are among the most diverse places on Earth. A single reef can be home to thousands of species. The Great Barrier Reef, off the coast of Australia, is so large it can be seen from space. It stretches for more than 2,000 kilometers, a city of life built entirely underwater, entirely from calcium. The sound of the ocean changes depending on where you are and what time of day it is. At dawn, it is often gentler. Small waves turning over slowly, the water retreating across pebbles with a soft, whispering rattle. By afternoon, the wind may have built the waves larger, and the sound becomes deeper, more rhythmic, like breathing. At night, under a quiet sky, the ocean seems to settle. The waves come in steadily, one after another, in a rhythm so regular it feels almost like a heartbeat. Waves are not water moving forward. That is one of the most surprising things about them. A wave is energy moving through water. If you watch a floating leaf in the sea, it rises and falls as a wave passes, but it doesn't travel forward. The water itself mostly moves in a circle, up as the wave approaches, forward at the crest, down at the back, and then returning to where it began. The energy moves, the water stays. This energy often starts far away. A storm somewhere in the middle of the ocean generates waves that travel for thousands of kilometers, gradually smoothing and lengthening as they go, until they reach a distant shore as long, gentle swells. The wave that breaks quietly at your feet may have begun as a storm somewhere on the other side of the world, days or weeks ago. The tides, the daily rising and falling of the sea, are caused by the moon. The moon's gravity pulls on the ocean, creating a bulge of water on the side of Earth closest to the moon, and another, slightly smaller bulge on the opposite side. As Earth rotates, these bulges sweep across the ocean, producing 2 high tides and 2 low tides in most places every day. The moon has been doing this for billions of years, patiently pulling at the sea, keeping the tides turning. In some places, the tidal range is dramatic. In the Bay of Fundy, in Canada, the tide rises and falls by more than 16 meters, higher than a 4-story building. At low tide, the seabed is exposed, wet sand and rocks and pools left behind, full of small creatures waiting patiently for the water to return. At high tide, all of that is submerged again beneath calm water, the same place, completely transformed twice a day. The ocean is salty and has been for most of Earth's history. The salt comes from rivers, which dissolve minerals from rocks on land and carry them to the sea. Over billions of years, the salt has concentrated. The ocean today is about 3.5% salt on average, though it varies. Saltier in warmer, drier places where evaporation is high. Slightly less salty near the poles, where melting ice dilutes the water. Salt water has a higher density than fresh water, which means it is slightly heavier. Cold salt water is denser still. In the ocean, these differences in density drive a global system of circulation, currents that move water slowly around the entire planet, like an enormous conveyor belt. Cold, dense water sinks in the polar regions, flowing along the ocean floor toward the equator, while warmer surface water flows toward the poles to replace it. This circulation takes about 1,000 years to complete one full cycle. The water at the bottom of the deep ocean may have last been at the surface a millennium ago. If you're still here, listening, you're doing beautifully. Let your breathing slow a little more. Let the sound of the ocean be something you can almost hear, softly, just at the edges of your thoughts. Rain is water's most familiar form, the one most of us have known since childhood, watching drops race down a window, or jumping in puddles, or lying in bed listening to the sound on the roof. Rain begins so small. A raindrop starts as a tiny particle of dust, or pollen, or sea salt floating in the upper atmosphere. Water vapor condenses around this tiny seed, forming a droplet so small You could fit millions of them on the head of a pin. These droplets form clouds, and a cloud is not, as it might seem, a soft, solid thing, but a vast collection of tiny water droplets or ice crystals suspended in the air. As droplets in a cloud collide and combine, they grow heavier. When they become too heavy for the updraft of warm air to support, they begin to fall. The typical raindrop you feel on your skin has fallen from about 2 kilometers above you, reaching the ground in roughly 2 minutes. A raindrop falling through air is not the pointed teardrop shape we usually draw. It is actually more like a tiny hamburger bun, flattened on the bottom by air resistance, rounded on top. Very small drops are nearly spherical. Larger drops flatten as they fall, and if they get too large, they split apart into smaller drops. No raindrop is the same shape for long. The smell of rain on dry earth has its own name, petrichor. It comes from oils that plants release during dry periods, which soak into the soil and rock. When rain falls, it disturbs these oils, releasing them into the air along with a compound called geosmin, produced by soil bacteria. The smell of rain is actually the smell of the earth waking up, the soil breathing out after a long dry spell. Rain falls differently in different places. In tropical rainforests, rain often comes in the afternoon, every day at almost the same time. A short, intense downpour that lasts perhaps an hour and then clears completely, leaving the air clean and glittering. In deserts, rain is rare and precious, and when it comes, it can seem violent. The dry ground unable to absorb it quickly, sending water rushing across the surface in brief, intense floods. In temperate places, the kind of climate many people know, rain is more varied. Gentle drizzle, steady gray downpours, sudden summer showers that arrive and leave in minutes. The lightest rainfall is called drizzle, and it is barely rain at all. More like the air itself has grown soft and wet, each droplet so small it almost floats. Walking through drizzle, you feel it on your face before you feel it on your clothes. Your hair goes damp before you realize it's raining. Drizzle is the quietest form of water. Fog is rain that never quite falls. It forms when the air near the ground cools enough that the water vapor in it condenses into tiny droplets. Too tiny to fall, just drifting. In a fog, you can feel the moisture on your skin. You can see only a short distance in any direction. The world becomes intimate and close. Sounds are muffled. Shapes at the edge of visibility look soft and dreamlike. Coastal fogs are common, where cold ocean currents run close to warm land. The cold air over the ocean gets pushed onto the coast, and wherever it meets the warmer air above the land, fog forms. San Francisco is famous for its fogs, which roll in from the Pacific in summer, spilling over the hills, filling the valleys, and then burning off by midday as the sun warms the air. In those morning hours, the fog has its own particular light, soft, diffused, shadowless. Dew is water that forms not from the sky, but from the ground upward. On clear, still nights, the ground loses heat quickly, and the air just above it cools. When it cools enough, the water vapor in it condenses on whatever surface it touches. Grass blades, leaves, spider webs, the roof of a car. You wake in the morning, and everything is coated in tiny drops, each one perfect and round, catching the early light. A spider web covered in dew is one of the most beautiful things in an ordinary morning. Some plants collect dew deliberately. Certain mosses and lichens can absorb water directly through their surfaces, surviving in dry places by gathering dew. The grass in coastal deserts may be covered in dew on many mornings, a small but vital supply of fresh water where no rain falls. Don't forget, you can check our playlist for more quiet stories just like this one. There's something for every night. Water underground takes many surprising forms. In limestone rock, water gradually dissolves the stone, creating caverns and tunnels and chambers over millions of years. These limestone caves are among the most extraordinary spaces on Earth. Stalactites hang from the ceiling like stone icicles, formed drop by drop over thousands of years as mineral-rich water evaporates and leaves behind a thin coating of calcium carbonate. Directly below, stalagmites grow upward from the floor, built from the same drops after they fall. A stalactite and stalagmite take about 100 years to grow 1 centimeter. In some caves, they have been growing for hundreds of thousands of years. Lakes are water at rest, and yet, even the most still-seeming lake is constantly in motion, at depths we cannot see, in ways we would never guess. A lake breathes with the seasons. In summer, the surface warms, and a layer of warmer, lighter water floats above colder, heavier water below. The two layers barely mix. Fish and plants live in their preferred zones, some near the warm surface, some in the cool depths. Then, in autumn, the surface cools and becomes denser, sinking through the warmer water below in a great, slow overturning. Nutrients from the bottom rise to the surface. Oxygen from the surface sinks deep. The lake stirs itself, redistributing everything it has been holding. This seasonal turning is called lake turnover, and it happens twice a year in many lakes, once in autumn, once in spring. After a cold winter, when the surface ice melts, the same thing happens. The cold meltwater, denser now, sinks and pushes the water below upward. The lake refreshes itself. This is why lakes in temperate climates remain healthy and oxygenated. They are stirred twice a year by the patience of the seasons. The world's deepest lake is Lake Baikal in Siberia. It is so deep, more than 1,600 meters, that it holds about 20% of all the liquid fresh water on the surface of Earth. 20%. All the Great Lakes of North America combined hold less than Baikal. It is ancient too, more than 25 million years old, making it one of the oldest lakes on Earth. Because it has been isolated so long, it has evolved species found nowhere else. The Baikal seal, a freshwater seal that lives only there. Tiny shrimp-like creatures that live deep in the water. A species of fish called the golomyanka, which is almost transparent and gives birth to live young rather than laying eggs. The Caspian Sea is the world's largest lake by surface area, larger than some actual seas, even though it is entirely landlocked, surrounded by land on all sides. With no connection to the ocean, it is salty, like the ocean, because it was once part of an ancient sea that gradually became isolated and enclosed. Its water evaporates, but the salt stays, accumulating over millions of years. Glacial lakes, those formed in valleys carved by glaciers, often have a remarkable, almost unreal color, bright turquoise, or vivid green, or deep blue-green. This color comes from rock flour, particles of stone ground so finely by the glacier that they are almost dust. These particles remain suspended in the meltwater, scattering light in a way that makes the water glow. Seeing a glacial lake for the first time, many people assume the color has been exaggerated or altered. It hasn't. The color is real. In winter, some lakes freeze. The process is slow and silent. As the temperature drops, the surface cools first. Ice begins to form at the edges where the water is shallowest. It spreads inward slowly, night by night, until one morning the entire surface is covered. The lake below continues its quiet life, protected by the ice above. Ice is less dense than liquid water, which is why it floats. This seems like a small thing, but it is one of the most important facts about water. If ice sank, lakes and rivers would freeze solid from the bottom up, and most aquatic life would not survive winter. Because ice floats, it forms an insulating layer on the surface, keeping the water below liquid and warm enough for life. Fish rest in the cold but unfrozen depths. Frogs burrow into the mud at the bottom and slow their bodies almost to a standstill, waiting for spring. Water striders, those long-legged insects that seem to walk on water, depend on a different property of water: surface tension. The molecules at the surface of water are more attracted to each other than they are to the air above, creating a thin, stretchy skin. This skin is strong enough to support the weight of a small insect, especially one with wide, flat feet that distribute its weight gently. A water strider's feet dent the surface slightly, but do not break through. If you watch one on a calm pond, you see the 4 small dimples its feet make, each casting a tiny shadow on the sandy bottom below. I hope you're settling in nicely. If this video is part of your bedtime routine, we'd love to know. Leave us a comment when you wake up tomorrow. We read them all. The surface tension of water is also why some flowers collect dew in their petals, pooling it like tiny bowls. The rose, the lady's mantle, these plants cup their leaves in ways that gather dew and hold it through the morning. Insects come to drink, the drops catch light. By midday, they are gone, evaporated back into the air, continuing their journey. Water and light together make some of the most beautiful things in the world. A rainbow forms when sunlight passes through a raindrop. As the light enters the drop, it slows slightly and bends, different colors bending by different amounts. Red bends the least. Violet bends the most. The light bounces off the back of the drop and exits, now spread into its spectrum of colors. To see a rainbow, the sun must be behind you and the rain in front. The center of the rainbow's arc is always the point directly opposite the sun. No two people ever see exactly the same rainbow, because the colors come to your eyes from a specific angle, about 42 degrees from the shadow of your head. And because your eyes are in a slightly different position from everyone else's, the rainbow you see is made of light from different raindrops than the one the person beside you sees. Your rainbow exists only for you. A double rainbow appears when light reflects twice inside the raindrop. The second bow is fainter and its colors are reversed. Violet on the outside, red on the inside. The sky between the two bows is often noticeably darker than the sky outside the outer bow. This darker band is called Alexander's dark band, named for a Greek philosopher who first described it in the 3rd century. Moonbows, rainbows made by moonlight, are rare and very faint. Moonlight is so much dimmer than sunlight that our eyes cannot easily detect the colors. We usually see a moonbow as a pale white arc. But in photographs Taken with long exposures, the colors emerge, soft and dreamlike, floating in the dark sky. Sunsets make water glow. The low angle of the evening sun means its light travels through more atmosphere before reaching your eyes, scattering away the short blue wavelengths and leaving the long warm ones, oranges, pinks, reds. Water reflects all of this perfectly. A calm lake at sunset becomes a canvas of warm color, the reflection so vivid it is hard to look away. The sun on moving water creates glitter, a shifting, dancing pattern of light that seems almost alive. This happens because the small waves on the water's surface act like tiny mirrors, each one tilted at a slightly different angle, each one catching and reflecting the sun from a different direction, all of them moving. If you watch it for a while, it becomes almost hypnotic. The light moving constantly, never forming a fixed pattern, always shifting. Bioluminescence is light made by living things, and the ocean at night can glow with it. Tiny organisms called dinoflagellates produce a blue-green light when they are disturbed. When waves break at night in bays where these creatures are concentrated, each crest glows briefly as it curls and crashes. Swimmers in bioluminescent bays see their arms and legs traced in blue-green light as they move through the water. Boats leave glowing wakes. Water is clearest where it is cleanest. In the clearest ocean waters, around remote Pacific atolls or deep coral reefs, you can see to depths of 40 or 50 meters. The water appears to have almost no color of its own, but at depth, the warmer colors are absorbed, and only blue remains. The deep, pure blue that photographs cannot quite capture. Rivers in flood carry sediment and are turbid and brown. Springs are clear. Glacial meltwater is milky. The color of water tells you its story, where it has been, what it has carried, how long it has traveled. Water in a glass can seem like the most ordinary thing in the world. And yet, when you look closely, really closely, you can see that even still water in a glass is not perfectly flat. At the edges, where the water meets the glass, it curves upward or downward depending on the material of the glass. This curve is called a meniscus. The water and the glass are having a conversation at their boundary, each one influencing the other. And the meniscus is the visible record of that conversation. Our playlist has many more stories just like this one for every night of the week. The link is always nearby when you need it. The water cycle is one of the most elegant systems in nature, circular, self-sustaining, endless. Evaporation begins anywhere. There is open water and energy from the sun. The sun warms the surface of the ocean, of lakes, of rivers, of puddles left after rain. Water molecules at the surface absorb this energy and move faster, fast enough eventually to escape the liquid and rise into the air as vapor. You cannot see this happening. Water vapor is invisible, but it is happening everywhere, all the time, on an immense scale. Each day, the sun pulls more than 1 trillion liters of water into the air from the ocean's surface alone. Plants contribute too, through transpiration. The water a plant absorbs through its roots travels upward, sometimes to great heights, in tall trees, and exits through tiny pores on the underside of each leaf. This movement is driven partly by the evaporation at the leaf surface, which creates a gentle pull through the entire water column inside the plant, from root to leaf tip. A large oak tree transpires several hundred liters of water on a warm summer day. As water vapor rises, it cools. Cooler air holds less moisture, and when the vapor cools past a certain point, it condenses, coming back together into the tiny droplets that form clouds. The temperature at which this happens is called the dew point, and it varies depending on how much moisture is in the air. On humid days, the dew point is close to the air temperature, which is why humid days feel heavy and close. The air is nearly saturated, nearly ready to condense. Clouds take many forms. The highest clouds, cirrus, are made not of water droplets, but of ice crystals, and they form wispy, streaky shapes high in the cold upper atmosphere. Cumulus clouds, the classic puffy white ones, are lower, built of water droplets, and they form on warm afternoons when thermals carry warm, moist air upward. Stratus clouds are flat layers that cover the sky like a gray blanket, bringing drizzle or light rain. Each type of cloud tells you something about the atmosphere, its temperature, its moisture, its movement. A thundercloud, a cumulonimbus, is a cloud that has grown very tall indeed. It can reach from near the ground to the very edge of the troposphere, 15 or even 20 kilometers up. Inside a thundercloud, ice crystals and water droplets collide and separate, building up enormous electric charges. When the charge becomes great enough, it discharges in a flash of lightning that heats the surrounding air to about 30,000 degrees Celsius, 5 times hotter than the surface of the sun. The air expands explosively, and we hear that expansion as thunder. But even in the gentlest cloud, something remarkable is happening. Hundreds of thousands of tiny droplets are constantly colliding and combining, growing heavier, drifting downward, then caught again by updrafts. This process, collision and coalescence, is how raindrops form and grow large enough to fall. A cloud drop may collide with 1,000,000 others before it becomes a raindrop heavy enough to descend. When precipitation falls through dry air that hasn't yet reached the ground, that is, it sometimes evaporates before landing. You can see this as streaks of rain hanging below a cloud in an otherwise clear sky. This is called virga, and it is one of the more striking sights in a dry landscape. Rain that almost makes it, dissolving back into the air before it touches the earth. Snow forms when the atmosphere is cold enough throughout its depth, when water vapor deposits directly onto ice crystals as they fall, building the intricate branching structures we know. A snowflake's structure is determined by the exact conditions it experienced at every moment of its journey: temperature, humidity, wind. And because no two snowflakes travel exactly the same path, the classic claim holds: no two are alike. Each one is the record of a unique journey through the sky. Water responds to cold in stages. At just above freezing, it becomes sluggish and thick. At 0 degrees Celsius, it becomes ice, a crystalline solid in which each water molecule is locked into a precise arrangement. But if you cool water carefully, without disturbing it, you can bring it below zero without it freezing, a state called supercooling. Touch it or shake it, and it freezes instantly in a beautiful spreading rush of ice crystals. This is why clouds at high altitude can contain liquid water droplets at temperatures well below freezing. Feel free to like this video if you're finding it peaceful. It means a lot, and it helps more sleepy listeners find their way here. Underground, water takes paths we never see. Water that soaks into the soil travels downward through pores and cracks, pulled by gravity, until it reaches a layer of rock or compacted clay that it cannot pass through. There it accumulates, filling the spaces in the rock above this barrier, creating what we call an aquifer. The upper surface of this accumulated groundwater is called the water table, and it rises and falls with the seasons, higher after wet weather, lower after drought. In some places, the water table is close to the surface, and you can find it by digging down just a few meters. In other places, arid landscapes, or places where too much water has been pumped out, the water table is very deep, and reaching it requires drilling far down through hard rock. Artesian wells occur where the water table in an aquifer is under pressure, usually because the aquifer is sandwiched between impermeable layers and receives water from a distant elevated area. When you drill into such an aquifer, the water rises on its own, sometimes all the way to the surface and beyond, flowing freely without any pump needed. The word artesian comes from the region of Artois in France, where such wells were common in the 12th century. Imagine water rising silently from the ground on its own, simply because of the geometry of the rock beneath you. Limestone is dissolved by slightly acidic water, and rainwater is naturally slightly acidic, having absorbed carbon dioxide from the air. Over millions of years, this dissolution creates extraordinary landscapes. The towers and pinnacles of karst landscapes, like those in southern China or parts of Slovenia, are made of limestone shaped by water. The rock has been slowly carved away everywhere except where it was most resistant, leaving these dramatic columns and ridges. Inside limestone landscapes, water has carved cave systems of immense complexity. The Mammoth Cave System in Kentucky, United States, is the longest known cave system in the world, with more than 600 kilometers of explored passages. These passages were cut by rivers that once flowed through them, dissolving and carrying away the limestone grain by grain over millions of years. Some passages are enormous, cathedral-like spaces where your voice disappears into the dark above you. Cave rivers still flow through some of these systems, underground rivers following passages carved long ago, sometimes surfacing as springs many kilometers from where they entered the ground. Mapping underground rivers was once done by pouring bright dye into a sinkhole and waiting to see where the colored water emerged days later, sometimes at a spring on the other side of a mountain. Rivers that disappear underground, swallowed by a sinkhole or a crack in the rock, are called sinking rivers. The point where they vanish is often abrupt and striking. The river is there, and then it isn't. It continues underground in the dark, navigating passages it carved itself. It may be gone for kilometers before it surfaces again, blinking into daylight. Geothermal water, heated by the Earth's interior, surfaces in volcanic regions as hot springs and geysers, as we mentioned, but also as fumaroles, where steam and volcanic gases vent from cracks in the ground. Mud pots are places where hot water and volcanic gases churn through clay, creating thick, bubbling pools of gray or reddish mud. They make a characteristic plopping, burping sound, each bubble of gas rising slowly through the heavy mud and bursting at the surface. The ocean floor has its own version of hot springs, hydrothermal vents. These form at mid-ocean ridges where the plates of Earth's crust are pulling apart and magma wells up from below. Seawater percolates down through cracks, is heated to several hundred degrees, and shoots back up through chimneys of mineral deposits. The water from these vents is superheated, far beyond boiling, but doesn't boil because of the intense pressure at the ocean floor. Around these vents, in the complete absence of sunlight, life thrives. Tube worms several meters long, shrimp, crabs, strange fish, all living on energy from the earth itself, rather than from the sun. This is the quiet miracle. Wherever water goes, life finds a way. Water shapes the land. Slowly, patiently, over time spans that dwarf the whole of human history. Water carves and carries and deposits, forming the landscapes we live in. The Grand Canyon in the American Southwest was cut by the Colorado River over the course of about 5 to 6 million years. The river carried sand and gravel that scraped the rock as it flowed, wearing it down, grain by grain. The canyon is now nearly 2 kilometers deep in places, and its walls expose layers of rock that span nearly 2 billion years of Earth's history. You can read the story of the planet in those colored bands, red and orange and purple and white, stacked one above the other. The river is still cutting, still carrying, still going deeper. River deltas form where rivers slow down and can no longer carry their sediment. The Nile Delta, the Mississippi Delta, the Ganges-Brahmaputra Delta. These are flat, marshy, incredibly fertile places built up grain by grain over thousands of years as the river deposits everything it gathered on its long journey. The Nile has been building its delta for about 10,000 years. Ancient Egyptian civilizations were made possible by the rich soil the river deposited there every year during floods. Sand dunes in deserts may seem like a world entirely without water, but they too were shaped partly by it. Many desert landscapes sit atop ancient riverbeds, rivers that flowed when the climate was different, when the rains fell more generously. The Sahara, which is now one of the driest places on Earth, was once much wetter. Rock paintings made by ancient peoples depict hippos, crocodiles, and cattle in places that are now completely arid. The water is gone, but the shapes it left in the rock remain. Fjords, those long, deep sea inlets in Norway, New Zealand, Chile, and other places, were carved by glaciers. The glacier moves slowly through a valley, deepening and widening it, and then the climate warmed, the glacier retreated, and the sea flooded the deep valley. The result is one of the most dramatic landscapes on Earth. Steep cliffs rising directly from dark, still water, their reflections perfect in the calm. Water also builds, not just carves. River sediment builds deltas. Coral polyps build reefs. Minerals dissolved in water crystallize and build stalactites, stalagmites, and the extraordinary cave formations called flow stones, smooth, layered sheets of calcite deposited over thousands of years as water flowed over cave walls. Hot springs deposit terraces of mineral-rich rock, like those at Pamukkale in Turkey, where white travertine terraces staircase down a hillside filled with warm, milky water that has been flowing and depositing there for thousands of years. Salt flats are formed when shallow lakes in arid regions evaporate completely, leaving behind a crust of salt and minerals. The Salar de Uyuni in Bolivia, the world's largest salt flat, covers more than 10,000 square kilometers and contains vast reserves of lithium beneath its salt crust. After rain, a thin layer of water covers the flat, creating a mirror so perfect that the sky and land become indistinguishable. Photographs taken there look like images from another world. Waterfalls are places where a river runs off the edge of something harder and drops. Niagara Falls moves enormous amounts of water, more than 2,000 cubic meters every second, and its sound can be heard kilometers away. But some of the world's most beautiful waterfalls are small and quiet, threads of water falling from mossy cliffs, or veils of mist descending through fern-filled gorges. Water finds the edge and lets go, falling freely, purely itself in those moments. If you're listening to this at night, you're in good company. So many of our listeners find this the perfect thing to drift off to. We're glad you're here. The sound of a waterfall is one of the most restful sounds in the world. Scientists who study sleep and relaxation have found that the sounds of moving water, rivers, rain, waves, help the brain release from its daily patterns, easing into rest. There may be a deep, old reason for this. Our ancestors rested near water. The sound of flowing water meant safety. It meant a place to drink, to wash, to gather. The sound has been in our lives for as long as we have existed. Even now, it still tells something ancient in us. Rest. You're safe. The water is here. Every culture that has ever existed on Earth has had a relationship with water, shaped by where water was, how much of it fell, how it moved. In ancient Egypt, the Nile was everything. It flooded every year, depositing dark, rich soil on the desert banks, and the farmers planted in this soil the moment the water receded. The flood was predictable and welcome. The god Happy was said to bring the inundation, and the people celebrated it. Egyptian civilization was, in the most literal sense, built on water. In the dry lands of the American Southwest, ancient peoples built elaborate systems of canals, acequia systems, to carry water from rivers to fields kilometers away. The Hohokam, who lived in what is now Arizona, built more than 1,500 kilometers of canals, some of them 7 meters wide and 2 meters deep. They maintained these channels for 1,000 years. Water was so precious that the entire culture organized itself around its management. In Japan, rice cultivation shapes the landscape. Paddy fields are flooded for much of the growing season, and the careful management of water, flooding, draining, timing the flow, is an art that has been practiced for thousands of years. The terraced rice fields of Asia, stepping down hillsides in long curved lines, flooded and reflecting the sky, are among the most beautiful human-made landscapes in the world. In the high deserts of the Middle East, people developed the qanat, an underground canal system dug by hand to bring groundwater from mountain aquifers to the dry plains below, using only gravity. The water traveled underground to prevent evaporation in the desert heat. Some qanats, built thousands of years ago in Iran and Afghanistan, are still functioning today, still flowing, still providing water to communities in the same places they always have. Ancient Rome built aqueducts, stone channels that carried water from distant springs to the city, sometimes for hundreds of kilometers. The water flowed entirely by gravity, the channels maintained at a very slight slope throughout their length. Roman engineers calculated this slope with extraordinary precision. Some Roman aqueducts are still standing. A few carry water today. The relationship between water and cities is always fundamental. Almost every great city in history was built on a river, for transport, for drinking water, for trade, for the rich farmland on the floodplain. London on the Thames, Paris on the Seine, Cairo on the Nile, Beijing beside rivers and canals. The city and the river have always lived together, shaping each other. In cultures where water is scarce, its sharing is governed by elaborate social rules. In the oasis communities of the Sahara, water rights, who may use which spring, at which time, for how long, were codified in law centuries ago and are still respected today. Water is community. Water is responsibility. Water is peace between neighbors. In wetter climates, water became a medium of beauty and contemplation. The garden ponds of Japan, the reflecting pools of Islamic gardens, the fountains of European palaces, these were all ways of bringing water close, of making its movement and stillness part of daily life, of letting it do what it does best: calm the mind, rest the eye, quiet the heart. Tonight, wherever you are, there is water nearby, in the pipes in the walls, in the clouds above the roof, in your own breath. Water is never far. Check our playlist whenever you need another quiet night. We have stories for every mood and every season. Water and plants together create some of the most soothing landscapes on Earth. A wetland is a place where water and land are so intertwined that you cannot always say where one ends and the other begins. Marshes, swamps, bogs, fens, each is a variation on this theme of water and earth living together. Wetlands are among the most productive ecosystems on Earth, despite being often overlooked or dismissed as wastelands. They filter water, store floodwater, support enormous numbers of species, and accumulate carbon in the peat beneath them. Peat bogs are extraordinary places. They form where the climate is cool and wet enough that dead plant matter accumulates faster than it can decay, because decomposition is slowed in the cold, acidic, waterlogged conditions. The peat builds up, sometimes for thousands of years, and the remains of plants that lived millennia ago are preserved in it almost perfectly. Ancient logs, seeds, insect wings, all held in the peat, unchanged. The water of a bog is often darkly stained like tea from the tannins in the peat. It is acidic and still, reflecting the sky in shades of amber. In tropical climates, the wetland becomes a mangrove forest. Mangroves grow at the edge of the sea, in the zone between land and ocean. Their extraordinary root systems, arching, tangled, spreading, providing the stability to grow in shifting sediment and salt water that would kill almost any other tree. These root systems create an underwater forest in their own right, a complex habitat for fish, crabs, shrimps, and countless other creatures. Mangrove forests protect coastlines from storms, absorbing the energy of waves before they reach the land. Water lilies have spent millions of years adapting to life on the water's surface. Their leaves are coated with a waxy substance that makes water bead up and roll off, a property called superhydrophobicity. The surface of a lily pad is covered in microscopic structures that trap tiny air bubbles under each water drop, causing the drop to sit up rather than spread, rolling off like a small globe. Engineers have studied this surface structure and tried to copy it in the design of waterproof coatings and self-cleaning surfaces. Reeds and bulrushes grow in the shallows of lakes and rivers, their tall stems swaying in the wind. their fluffy brown seed heads dispersing seeds on the breeze. Reed beds are important habitats for birds. Reed warblers nest there, invisible in the stems, singing their buzzing, churring song. Marsh harriers hunt over the reed beds, gliding low, watching. The wind moves through reeds with a constant, whispering sound, one of the quietest, most peaceful sounds in nature. Willows grow beside rivers and streams, their long, trailing branches often touching the water. In spring, before their leaves open, willows produce catkins, soft, silver-gray, fuzzy structures that stand up from the branches. Willows can root from almost any part of their stem. A branch broken off and fallen into the river may drift downstream, lodge in the mud at some bend, and root there, growing into a new tree. Moss grows anywhere that is reliably moist, on rocks beside streams, on the shaded side of boulders, on the floors of mountain forests. Mosses have no roots. They absorb water directly through their leaves, drinking in whatever reaches them. A cushion of moss can hold many times its own weight in water. When you press it gently and then release, it springs back slowly, releasing a tiny amount of moisture. Moss is like a sponge that the forest carries in its understory. Water, plants that grow underwater, face the challenge of obtaining light through the water column above them. Some have very finely divided leaves, feathery, delicate, which offer more surface area to catch the filtered light. Others grow long stems to reach the surface, where their leaves can float and catch sunlight directly. The underwater world of a clear lake or river seen through the water from above is a slow, swaying world of pale green and gold, plants moving gently in the current, fish drifting among them. If you've been listening for a while, perhaps your eyes are already feeling heavy. That's exactly as it should be. The way water moves is one of nature's most endlessly varied spectacles. A river in full flood is something powerful and wide and unstoppable. But a river in summer low water is something else entirely. Intimate and clear, its bed visible, every stone and pebble distinct, the water moving in patterns you can follow with your eye. The smooth tongue of the current at the head of a pool, the riffles over shallower gravel, the slow, deep bend where the water turns amber in the evening light. Eddies form behind any obstacle in a current. Behind a boulder in a river, the water curls back on itself, moving upstream for a moment before rejoining the main flow. Eddies are calm places, leaves and foam collect in them. Small fish rest there, out of the main current. If you are canoeing or kayaking on a river, learning to read eddies is fundamental. They are your rest places, your pauses. A weir, a low dam across a river, creates a standing wave. The water pours over the lip of the weir and then wells up again, creating a wave that stays in one place while the water moves through it. Kayakers play in standing waves for the same reason surfers play in ocean waves. The joy of holding a position in moving water, balanced precisely between the pull of the current and the push of the wave. Tidal rivers, rivers near the sea, run in two directions. When the tide is coming in, the sea pushes salt water upstream, and the river seems to flow backward. When the tide turns, the river asserts itself again, pushing fresh water toward the sea. In the zone where fresh and salt water mix, the estuary, the water is brackish, a mixture of both, and it shifts with every tide, Some fish are adapted to this in-between world, tolerating both salinity levels as they move between the sea and fresh water for different parts of their lives. Salmon are the most famous migrants in fresh water, returning from the sea to the rivers where they were born, swimming upstream against the current to spawn. The journey can take weeks. They navigate, scientists believe, partly by the magnetic field of the Earth and partly by the distinctive smell of the water of their home river, which they memorized as juveniles. Each river has a slightly different chemical signature, a fingerprint in the water, and the salmon follow it home. In the deep ocean, currents move with a slowness that is almost meditative. The great thermohaline circulation, the ocean's global conveyor belt, moves water from the tropics to the poles and back, distributing heat around the planet. Without it, the climate of much of the world would be radically different. Britain and Ireland, for example, are far warmer than their latitudes should suggest, partly because the Gulf Stream carries warm water from the tropics to the North Atlantic. The ocean moderates the world. Wave trains, groups of waves, move in organized patterns. When a storm generates waves, the longer, faster waves travel ahead of the shorter ones, sorting themselves by period as they cross the open ocean. By the time they reach a distant shore, they arrive in a regular procession of long swells, beautiful, smooth, evenly spaced, that seem to rise from a calm sea with no apparent cause. The sound of waves breaking on a beach is a sound that human beings have been hearing for as long as there have been human beings. It is in our oldest memory, somewhere below conscious thought. That sound slows the breath and quiets the mind without any effort on our part. It does this by itself, simply by being what it is. Don't forget, our playlist is full of quiet stories for nights just like this one. We hope it keeps you company. There are facts about water so simple and so surprising that they can make you stop and look at a glass of water as if you've never really seen it before. Water is the only substance on Earth that naturally exists in all three states, solid, liquid, and gas, within the range of temperatures and pressures that occur at Earth's surface. On a cold winter day, you might see all three: ice on a puddle, liquid water in the puddle, and water vapor rising as steam from a warm spot nearby. The hydrogen bond, the particular way water molecules are attracted to each other, is the reason water has so many of its remarkable properties. Water molecules are slightly polar, meaning one end is slightly positive and the other slightly negative. This makes them attract each other in a network of weak bonds that are constantly forming and breaking. This network is why water has such high surface tension, why it takes so much energy to heat and evaporate, and why ice floats. Water has a very high specific heat, which means it can absorb a lot of heat without changing temperature much. This is why the ocean acts as a climate moderator. It warms slowly and cools slowly, smoothing out temperature extremes. It is also why coastal climates are milder than inland ones. The sea absorbs summer heat and releases it in winter, keeping temperatures more even. Pure water is completely colorless, odorless, and tasteless, a perfectly neutral substance. The taste we associate with water comes entirely from the minerals dissolved in it: calcium, magnesium, potassium, sodium, trace elements from the rocks it traveled through. Some people can detect very small differences in the mineral content of water from different sources. The taste of a mountain spring water is different from the taste of deep aquifer water, and both are different from desalinated seawater, which lacks almost all minerals and tastes flat and empty. Water is nearly incompressible. You can push it, you can freeze it, you can heat it. But squeezing liquid water into a smaller volume takes enormous pressure. At the bottom of the Mariana Trench, the pressure is about 11,000 times that at the surface, and even under that immense pressure, water is only about 5% denser than at the surface. This incompressibility is why hydraulic systems work. Pressure applied to water in one place is transmitted equally throughout. The color blue is associated with water in nearly every culture, though water itself is technically nearly colorless. The slight blueness of deep, clear water comes from water's absorption of red wavelengths of light, very subtle but visible in large volumes. A glass of water shows no color. A swimming pool shows a faint blue. The deep ocean is intensely, profoundly blue. The same substance. The depth of the color depends on the depth of the water. Water and fire seem like opposites, but they cooperate in nature too. Wildfires are followed by rain. Often, the ash and nutrients left by fire become rich soil, and the first rains bring an explosion of new plant life. Hot springs and volcanic vents blend fire and water directly, creating conditions for life that exists nowhere else. The word water is one of the oldest words in the English language, descended directly from Old English without significant change. Words for water are among the oldest and most stable words in almost every human language, because water has always been there, always been central, always needed a name. Human bodies are about 60% water. The brain is about 75% water. Blood is over 90% water. We are, in a very real sense, walking bodies of water. Water that has learned to move and think and breathe. This realization that we are mostly water can feel strange or can feel deeply comforting, depending on how you hold it. Perhaps comforting is the right way. We are part of the water cycle, part of the great movement of water through the world. The water in us has been elsewhere, in the sea, in the soil, in ancient rain, and it will be elsewhere again someday. For now, it is here, in us, making us possible. If this story has been a comfort tonight, consider leaving a like. It truly helps others find this quiet place. Water has a particular relationship with the night. In the night air, particularly on clear, still nights, dew forms. The temperature drops, and surfaces lose heat faster than the air, cooling below the dew point. Water from the air condenses on anything that can cool enough. Grass blades, leaves, metal, stone. In the morning, the world is freshly covered in this thin layer of water, each surface glistening, each drop catching the early light. Nocturnal animals use water in particular ways. Frogs and toads are drawn to standing water at night to call and breed. Their calls, the chorus of frogs on a warm summer night around a pond, is one of the most evocative sounds in nature. Each species has its own call, the low hum of a bullfrog, the high trilling of a tree frog, the wooden clicking of a chorus frog. A full frog chorus on a humid night is its own kind of music, layered, continuous, ancient. Fireflies, in the regions where they live, often gather near water. The light they make is produced by a chemical reaction called bioluminescence, and they use it to find mates. In some parts of East Asia, thousands of fireflies synchronize their flashing, all blinking on and off in unison along the banks of a river, creating a sight that seems impossible. A living light show reflected in the still water. The moon on water at night is something that painters and poets have returned to again and again, across every culture and every century. Moonlight is softer than sunlight, reflected and diffused, and on water it appears as a column of shimmering silver light reaching from the shore to the moon's reflection. When the water is calm, the moon's face looks back at you from the surface. When there are small ripples, the reflection breaks into 1,000 pieces, each one a tiny moon. Water at night is often quieter than water in the day. Less wind, less disturbance. A lake at midnight can be as smooth as glass. You could throw a stone and watch the ripples spread in perfect, widening circles until they fade to nothing, and the lake is still again, as if nothing had happened, as if the stone and you and the throw were all a dream. Stars reflect in still water. Looking down into a dark lake on a clear night, you can see the stars below as well as above, the same sky, upside down, trembling very slightly. In this moment, between the sky above and the sky below, you feel suspended between two infinities. Rain at night has a particular texture of sound. It comes to you first as a change in the quality of the silence, a soft percussion arriving before you're quite sure it started. Then the drips on the roof, the trickle from the eaves, the gathering rush on the pavement. Rain at night seems closer than rain in the day, more intimate. You are inside, the water is outside, and the boundary between these two conditions is just a thin wall, and you are very warm, and the rain is making its patient sound. In deserts, the night brings dew even when no other water comes. Desert plants have adapted to collect it. Waxy leaves, smooth surfaces, strategic angles. The Namib desert beetle uses tiny bumps on its back to condense water from fog, channeling it to its mouth. The cactus uses its spines to collect dew. Life, in the driest places, has learned to drink from the night air. The night sky itself holds water. The clouds of gas in space contain water molecules. Steam jets from comets as they approach the sun. Water vapor is found in the atmosphere of other planets. Water is not unique to Earth. It is scattered throughout the universe. But liquid water on the surface of a planet in the gentle range of temperatures where life can use it, that is the extraordinary thing. That is what makes the rain on your window, the stream in the valley, the glass beside your bed so precious. We have traveled a long way with water tonight. From the high glaciers, where the ice holds billions of years of the world's breath, down through mountain streams and river valleys and deltas, all the way to the deep ocean where the water is cold and dark and the pressure is so great that even the rocks are compressed. We traveled underground through limestone caves and secret aquifers and artesian wells. We rose with the mist from the morning fields and gathered in clouds above the mountains and fell again as rain on dry earth, releasing the smell of the world waking up. We floated on the surface tension of a pond, drifted in a river eddy, settled into a quiet lake at sunset. We found bioluminescence in the deep ocean and dew on a spider's web, and the moon reflected in still water. We breathed with mangrove forests and stood at the edge of a salt flat that reflected the entire sky. We heard rain on a roof at midnight and frogs calling from the edge of a summer pond, and the soft, even sound of waves. Water has been with us the whole time, as it has always been. It was here before the first life, before the first fish, before the first forest, before the first person stood at the edge of a river and felt something quiet settle in their chest. Water has been making that sound of movement and rest, of falling and gathering, of emptying and filling, for longer than there have been ears to hear it. And it will continue when we are gone. The water cycle does not need us. It turns by itself, sun and gravity and the patient physics of molecules. And it will continue turning for as long as the sun shines and the planet holds together. The raindrop falling now outside some window in the world may fall again in a different time, in a different place, on different ground, and it will still be the same raindrop, the same water, the same ancient traveler. You are made of this. The water in your blood and your breath and your tears is the same water that has always been here, rearranged and recombined and redistributed, but never lost, never created, simply moving through its long circular journey. Tonight, you rest. The water rests with you, in you, around you, in the soft, dark air. There is nothing to do now but be still. Let your breath come and go like the tide. Let your thoughts settle the way water settles in a quiet basin, slowly stilling, the ripples fading to nothing. The ocean is breathing at the edge of some distant shore, in and out, in and out. A river somewhere is finding its way around a bend. Rain is falling on a forest, and the leaves are receiving it, and the soil is drinking it, and the roots are carrying it upward toward the light. There are places on earth where water does something that seems impossible. It turns to stone, not literally, but the mineral-rich water of certain springs deposits layer upon layer of calcium carbonate as it flows, building structures that look like frozen waterfalls, like stepped terraces, like the inside of a slow dream. Pamukkale in Turkey, whose name means cotton castle in Turkish, is one of these places. Warm, mineral-rich spring water has been flowing down a hillside there for thousands of years, cooling and depositing calcium carbonate as it goes, building terraces of white stone filled with pools of pale blue water. The structure looks impossibly delicate, impossibly white, almost like snow that never melts. Travertine, the stone built by mineral-rich water, has been used as a building material for millennia. The Colosseum in Rome was built largely of travertine, quarried from deposits formed by ancient springs. The stone that tourists run their hands across today was laid down by water that flowed thousands of years before the building existed, each layer the record of a moment when mineral-rich water paused, cooled, and gave something of itself to the earth. Limestone itself, the rock that covers so much of Earth's surface and underlies so many of the world's great rivers and cave systems, is made of water's ancient work. Most limestone formed from the shells and skeletons of marine creatures that lived in ancient seas. When those creatures died, they sank, and their shells accumulated in layers on the seafloor, compressing under their own weight over millions of years into rock. When you walk on limestone, in a cave, on a cliff, on a pavement in a city, you are walking on the remains of tiny sea creatures that lived in a warm, shallow sea that may have existed long before there were any land animals at all. Chalk is a softer form of this same story. formed from the shells of microscopic marine algae called coccoliths, which lived in vast numbers in warm, shallow Cretaceous seas about 100 million years ago. The famous white cliffs of Dover in England are made of chalk. Billions and billions of tiny shells pressed together, now exposed at the edge of the sea, white against the gray water below. The cliffs are slowly being eroded by the waves, the sea taking back, grain by grain, what the sea once made. Water dissolves minerals from rock and carries them in solution. Invisible, dissolved, transformed from solid stone into something that flows. When the water evaporates, or changes temperature, or encounters a different chemistry, those minerals come back out of solution as crystals. This is how the extraordinary mineral formations inside geodes are made. Water seeps into a hollow in volcanic rock and deposits silica molecules, slowly, one by one, building quartz crystals that grow inward from the walls. Cracking a geode open is like opening a small room that has been accumulating its decorations for millions of years. Salt crystals grow in dry lake beds where mineral-rich water evaporates under a hot sun. In Bolivia's Salar de Uyuni, the surface of the salt flat is tiled with hexagonal patterns, the edges of salt crystals, each one the shape that salt always makes when it crystallizes. Cubic, precise, defined by the geometry of sodium and chloride atoms. These crystals grow slowly as brine near the surface evaporates. When rain falls on the flat, a thin mirror forms above them, and in that mirror, the entire sky is doubled. Cave pearls are formed by water too. In some limestone caves, water drips into a small depression and swirls gently, depositing calcium carbonate around a tiny grain of sand or grit at the center. Over years and decades, the concentric layers build up into a perfect sphere, smooth, lustrous, lying in a shallow pool of water, looking exactly like a pearl, but made entirely of stone. Some cave pearls are the size of golf balls. They form with no living thing involved, just water, minerals, and time. Stalactites and stalagmites grow by the same patient process. Each drop of water that hangs from a cave ceiling deposits a fraction of a milligram of calcium carbonate before falling. Over 1,000 years, this builds a centimeter of stone. Over 100,000 years, a stalactite, a meter long. The shapes they take are determined by tiny variations in the drip, how fast it falls, how much mineral it carries, what the airflow in the cave is doing. Some stalactites are pure and straight. Some twist and curl. Some grow in curtains, thin, translucent sheets of stone that ring like glass when tapped gently. Water and stone are in a conversation that never ends. The stone shapes the water's path, forcing it through this crack, around that boulder, over this lip. The water shapes the stone in return, wearing it, dissolving it, carrying it away, grain by grain, depositing it elsewhere. Over enough time, the water usually wins. The stone becomes the valley, the crack becomes the cave, the mountain becomes the delta. And the water moves on, looking for the next conversation. Like this video if you'd like to. It's a small thing that means a great deal, and it helps sleepy listeners like you find their way here. Minerals carried by water give springs their character. Iron-rich springs stain the rock around them orange and red. Sulfur springs produce water with a distinctive egg-like smell. Calcium-rich springs deposit white crusts on anything the water touches. In Iceland, the geothermal springs produce water of extraordinary blue-white opacity, milky with silica particles. and the lagoons of this geothermal water, set against the black volcanic rock, look like scenes from a world before ours. Water and the sky are always in conversation. Clouds are that conversation, made visible. A cloud begins as nothing, a slight cooling of air, a tiny particle of dust or pollen or sea salt. Around that particle, invisible vapor condenses into a droplet too small to see. Then another droplet forms nearby, and another, until there are millions, billions of them, so small and so light that the air holds them up, and we see their collective presence as a soft, bright shape against the blue. Every cloud is different. No two have ever been exactly the same shape. Even a single cloud changes constantly, its edges evaporating and reforming, its interior billowing and shifting as warm air rises through it and cold air sinks. A cloud is not a thing so much as a process, water cycling through visibility into and out of form, moment by moment. Lenticular clouds form over mountains when moist air is pushed upward over a peak and cooled, then warms again as it descends on the far side. The cloud forms at a fixed altitude in a fixed position, hovering perfectly still above the mountain while the wind streams through it. To someone who doesn't know what they're looking at, a large lenticular cloud over a mountain peak can look remarkably like a disk, smooth, symmetrical, glowing at its edges in the slanted light of morning or evening. They have caused many a startled report over the centuries. Mammotus clouds hang in rounded pouches below the flat base of a large cumulonimbus. They form when cold, heavy air laden with ice crystals sinks in pockets from the base of the cloud, creating those distinctive bulges. A sky full of mammotus clouds, lit golden or orange in the evening light, is one of the most dramatic and beautiful sights that weather can produce. They look as if the sky has grown a second skin, a soft and heavy one, pressing downward. Noctilucent clouds are the highest clouds in the atmosphere. They form at about 80 kilometers altitude near the edge of space, from ice crystals forming around meteoric dust. They are only visible in the deep twilight of summer nights, when the sun has set below the horizon for observers on the ground, but still illuminates these very high clouds from below. They glow with a pale, electric blue-white light that is unlike any other color in the sky, bright but unearthly, shimmering faintly. They are seen only at high latitudes, where summer nights barely darken. The sky itself changes color because of water in the air. On humid days, the atmosphere scatters light differently. Haze softens the blue and makes distant hills look pale and faded. On clear, dry days after rain has washed the air clean, the blue is almost impossibly deep, and distant objects seem closer, sharper, more vivid than usual. Photographers know this. The light after rain is different from any other light. Halos around the sun and moon are made by ice crystals in high cirrus clouds. The crystals, tiny hexagonal prisms, refract light as it passes through them, bending it by a precise angle that produces a ring of light 22 degrees from the sun or moon. Inside the halo, the sky is slightly darker. Sometimes a second halo forms at 46 degrees. Sundogs, bright spots of light on either side of the sun at the same altitude, are also made by ice crystals, those lying flat and acting as tiny prisms, bending sunlight to the side. On a cold, clear morning with high cirrus, you might see the sun flanked by two bright false suns, each one faintly colored each one a gift of ice and light. Crepuscular rays, those beams of light that appear to radiate from the sun, especially near sunset, are made visible by particles in the air, dust, water droplets, smoke. The rays themselves are parallel, but they appear to fan out from the sun because of perspective, the same way train tracks seem to converge at the horizon. When crepuscular rays are particularly dramatic, they can span nearly the entire visible sky, from just above the horizon on the sunset side to the opposite horizon, where they converge again in what are called anti-crepuscular rays. Standing at the center of this, with light radiating from both directions, can feel like being briefly inside something vast and luminous. The aurora borealis sometimes appears above water in the far north, and its reflection in a dark, still lake doubles the experience entirely. The curtains of green and sometimes pink and violet light shift and fold in the sky above. The same curtains shift and fold in the water below. Between the two, standing on the shore of a lake in northern Norway, or Canada, or Iceland, you are surrounded by light that is made by particles from the sun colliding with the highest layers of the atmosphere. Space weather made visible as color, and water shows it to you twice. Our playlist has many quiet evenings waiting for you, all kinds of natural worlds to drift through on nights when sleep is slow to come. Rain changes the sky in the moment of falling. The air cools noticeably even before the rain reaches the ground. You can feel the temperature drop and the wind shift as the leading edge of a rainstorm approaches. The rain itself creates a curtain in the air, gray and shifting, moving across the landscape in visible waves. Watching a rainstorm approach from a distance, from the window of a warm room, or from the cover of a large tree, is one of the most satisfying experiences that weather offers. The storm arrives at its own pace, without hurry, and passes in its own time, leaving the air clean and the world shining. After rain, if the sun appears low in the sky, every surface that holds water becomes a mirror. Puddles reflect the clouds. The wet road reflects the streetlights. Every leaf holds a drop that holds a tiny curved image of the world around it. For a little while, after rain, the world is doubled, itself and its reflection, side by side, and the line between them almost invisible. We have traveled a long way with water tonight. From the high glaciers, where the ice holds billions of years of the world's breath, down through mountain streams and river valleys and deltas, all the way to the deep ocean where the water is cold and dark and the pressure is so great that even the rocks are compressed. We traveled underground through limestone caves and secret aquifers and artesian wells. We rose with the mist from the morning fields and gathered in clouds above the mountains and fell again as rain on dry earth, releasing the smell of the world, waking up. We floated on the surface tension of a pond, drifted in a river eddy, settled into a quiet lake at sunset. We found bioluminescence in the deep ocean and dew on a spider's web, and the moon reflected in still water. We breathed with mangrove forests and stood at the edge of a salt flat that reflected the entire sky. We heard rain on a roof at midnight and frogs calling from the edge of a summer pond and the soft, even sound of waves. We swam alongside whale sharks and watched flying fish leap between two worlds. We stood inside a cave where stalactites had been forming since before the pyramids were built. We watched a lenticular cloud hover above a mountain, perfectly still, while the wind moved through it. We saw aurora light reflected in a lake at the edge of the world, doubled. The sky above and the sky below, the same light everywhere. Water has been with us the whole time. It was here before the first life, before the first fish, before the first forest, before the first person stood at the edge of a river and felt something quiet settle in their chest. Water has been making that sound of movement and rest, of falling and gathering, of emptying and filling, for longer than there have been ears to hear it. And it will continue when we are gone. The water cycle does not need us. It turns by itself, sun and gravity, and the patient physics of molecules. And it will continue turning for as long as the sun shines and the planet holds together. The raindrop falling now outside some window in the world may fall again in a different time, in a different place, on different ground. And it will still be the same raindrop, the same water, the same ancient traveler. You are made of this. The water in your blood and your breath and your tears is the same water that has always been here, rearranged and recombined and redistributed, but never lost, never created, simply moving through its long circular journey. Tonight, you rest. The water rests with you, in you, around you, in the soft, dark air. There is nothing to do now but be still. Let your breath come and go like the tide. Let your thoughts settle the way water settles in a quiet basin, slowly stilling, the ripples fading to nothing until the surface is smooth and dark and peaceful, holding the sky. The ocean is breathing at the edge of some distant shore, in and out, in and out. A river somewhere is finding its way around a bend. Rain is falling on a forest, and the leaves are receiving it, and the soil is drinking it, and the roots are carrying it upward toward the light. And you are here, warm and quiet and safe, held gently by this moment. Let your eyes close if they haven't already. Let the sound of water be something you carry with you into sleep, a soft murmur at the edge of your dreaming, the sound of the world doing what it has always done. Rest now. The water will keep moving while you sleep. It always does. You don't need to watch over it. Everything is flowing exactly as it should. Good night.